Welcome to the Salmon Runs YouTube. Enjoy the video.
You start by matching the flight controller to the airframe and mission. Identify frame size and motor kV so you know processing needs. Once done, pick an MCU family. F4 handles basic flight, F7 enables advanced telemetry and filters. Make sure to verify connector types like UART, I2C, S-Bus, and CAN because peripherals must plug in. Also confirm physical mounting pattern and vibration isolation options. This gets you past guesswork and into a concrete shortlist of compatible controllers. Next, evaluate sensors and firmware support so your controller performs reliably in real conditions. Compare IMUs. Some boards use MPU 6000 for robustness, while others use ICM 20689 for lower noise. Include barometer or magnetometer if you need altitude hold or compass-assisted navigation. Check power architecture. Built-in PDB, 5V regulators, VBAT sensing, and telemetry pins from ESCs. Finally, verify firmware compatibility. Betaflight for racing, INAV for navigation, Ardu Pilot for advanced autonomy. Finally, install and validate the controller following a strict checklist. Mount with vibration isolation and solder ESC3. 3/5V and VBAT properly. Secure common grounds. Once powered, flash chosen firmware, set board orientation, and run accelerometer, gyro, and ESC calibration. Map your radio channels and test actuators with props off. If you encounter flight issues, check black box or firmware logs. Verify IMU orientation and inspect solder joints. If vibrations persist, change mounting or update filtering before the first tethered hover.
Thanks for watching. Consider subscribing if we helped you.